Hey everyone, and welcome to Kongcast. I'm Kaitlyn Barnard, and in this series, we chat with software developers and technology leaders to tackle your biggest connectivity challenges. I am super excited today to welcome Chris Parlette, Senior Solutions Architect at TriggerMesh. So, Chris is going to be talking to us today about event-driven architecture.
Thanks, Kaitlyn. I'm excited to be on the Kongcast.
So one of the things we really like to start with is, kind of getting a little bit of a sense for your background, how you ended up in this specific technical space. So, what's kind of your background on where you've come from and how you got to TriggerMesh?
Yeah, so I went to school at University of Maryland. It seems now like a long time ago. Doing computer programming, computer science, and so when I started working, I found out that I really liked the startup culture. So I joined a small company. And it was a open source monitoring tool, and that was kind of my first job. That's actually where not to jump ahead, but that's actually where I met our current CEO, the CEO of TriggerMesh, Mark. We actually met and worked together at that first company that I worked at called Xenos. And so I went to a couple different software startups. So I've been doing things like I was doing professional services work, so doing custom development, mostly Python. And then I kind of got more into the pre-sales roles, kind of doing a sales engineer kind of thing. And now, as is with most startups, the role is a lot of different things, right? So I do sales engineering. The engineers think I'm a sales guy. The sales guys think I'm an engineer. But I also help with marketing. I write blog posts, do videos. So anything that I can help with, I'm happy to help with. But so that's kind of how I've been going along my path. And then I got into cloud. I was doing a lot of stuff with cloud cost management and kind of development around that. And then I really started getting more into this Kubernetes space. And so that was where, again, I have known a couple of the people who work at TriggerMesh from before, and I've been keeping an eye on TriggerMesh, and it was something that was very interesting to me, just kind of what they were doing in the Kubernetes space and, the cloud native space and serverless. So I was kind of already interested in that. And then, they had an opening and I jumped on it because I just think this is really cool, leading edge technology.
I love it. Yeah. It's been kind of a serendipitous, I think, relationship because I feel like Mark knows everyone and there's a lot of overlap with the TriggerMesh team.
Y- y-
But yeah.
Yeah, I think Mark said he knows at least a couple of people at Kong from a long time ago. Mark seems to know everybody, so
Yeah.
it's great. And then the other co-founder Sebastian, he lives over in Switzerland, and I think he kind of knows everyone in that Kubernetes space. He wrote one of the original serverless on Kubernetes tools, and so yeah, it's just I
Yep.
think he kind of knows everybody in that space too. And I think Kong and TriggerMesh are kind of adjacent in a lot of ways in those kind of spaces.
Yeah, and it's been this really fun. I don't know. I've enjoyed it. My background in the past is in the Kubernetes and CNCF space as well, and I've just really enjoyed kind of this overlap within the community because there have been all these amazing, just overlaps with technologies and integrations and stuff like that. So I'm kind of excited to dive into that today because I feel like this is a trend we're seeing across the board.
Excellent. Yeah, I agree. It is interesting, like the idea of APIs, Kubernetes. A lot of people who are into some of that again cutting edge technology. They tend to kind of touch on a couple different pieces, and
Yeah,
it seems like there's a lot of overlap in a lot of those tools.
yeah. So, like I said, what we're talking about today is this, event driven architecture overall. And I'd really like to start at the beginning, just kind of with the basics of can you define for the audience what does event driven really mean? And, kind of how does this compare to the previous ways of really doing things?
Yeah, so event-driven architecture, it's definitely become more popular. I think for a while there was this idea of like monolith versus microservices, and that's kind of been a thing, sort of a design principle. And I think it's almost like an evolution of microservices because it's kind of like the next step of that, which is this event-driven architecture. So I think with microservices, one of the and people might debate me on this, but I think one of the limitations is typically with microservices, you are developing or your organization is developing all of the microservices. But sometimes you don't really work in that isolation, right? I mean, if you work in any company, we're a startup and we have connections to Salesforce and to different cloud providers and some on-prem stuff and Slack and Google Docs, and it's just like you have stuff everywhere. So this idea of microservices is like, oh, I'm going to control each individual service. And it's like sometimes there's just services that you don't control. So in my mind, at least, a lot of times the event-driven architecture piece comes in of, okay, you have to integrate with tools that you don't own, but you also have to integrate with tools that you do own. So some of your custom stuff, and then integrating with all these different things. It exists everywhere. You're connecting to everything. You're trying to speak the same language across all these different things, and it's like sometimes that's hard to do. So I think where you kind of get into some of these event-driven architectures, or kind of that event-driven infrastructure, or any of these kind of platforms, if you want to call them that, the idea really is just like trying to make it easy to connect to all this stuff, right? And I think by making it easier, then what we aim to do, at least, and I think what a lot of people aim to do with event-driven architecture, is let their developers just develop. Like, okay, you're building the business logic and trying to do cool stuff that makes our business run better. You don't have to worry about what is the API for making a Slack call, or how do you pull data in from our Salesforce CRM. It's like you don't want them worrying about that. So instead, what we do is we kind of put some of that plumbing in place so that you can just say, okay, you're a developer, here's an API, or you know what, accept this event. Here's the defined event, attributes and data, and then you can do something with it, right? You can do whatever it is you need to do with it, but it's like we're defining it. We're defining the API that you need to send it to, and they can just go and do what they need to do. So to me, that's kind of where event-driven architecture comes in again, as more of an evolution of that, the idea of microservices, or kind of splitting things out. It's like, yeah, you split things out, but now you need them to communicate better, and that's sometimes hard to do. So that's kind of what we're trying to solve.
Absolutely, absolutely. And I feel like that's a really nice segue into, my next question here is event-driven architecture isn't necessarily new, but I feel like it's picking up a lot just recently. We're hearing more and more about it. What is driving that?
Yeah, I think again, as these organizations, anytime you look at the IT sprawl of an organization, especially companies that have been around for a long time, it's just you just have stuff everywhere. You have old stuff, you have new stuff. You're trying to stay on top of modern technologies, but you can't just rip everything out and go to go to let's jump on AWS and just leave everything behind. It's like sometimes that just doesn't work, right? So as someone who works in cloud, I'd love for it to work, but it's just not the way the world works. So, you know, kind of, bridging some of that, the old and the new, the legacy and the modern, if you want to call it that. Taking all of the application and business logic that you've already written, and instead of just tearing it out, like trying to use what you have and bring it modern. Because you do want to get the benefits of some of the modern tooling, right? You want to get the benefits of Kubernetes. You want to get the benefits of cloud native. You want to get the benefits of all of that, but you want to again take some of that old stuff and kind of pull it up to the modern. So I think, like you said, event driven events have been around forever. We work with literally mainframes, and we'll kind of talk about this later, but we work with mainframe technology. Well, that's spitting out events too, right? It has message queues. It's just that sometimes the things that come out of that, you don't know what to do with it, right? Because it's just some legacy format, and you're just like, how do I even connect to this thing? So by bringing that to the modern technology, then it's like, okay, you still have the mainframe stuff doing what it is it does, but you're able to work with it in JSON on a AWS SQSQ or something like that. So by kind of bringing that technology together, it helps you move to the modern stuff while not just completely ditching all the stuff that you've done.
Right. And I think we saw this a lot with Kubernetes, right? When Kubernetes started picking up in the market, everybody wanted to move. And it's
Right.
not just something you can do overnight, right? Like that's a huge undertaking. So there's so much value in that kind of gradual modernization, and being able to kind of bridge that gap between the old and the new.
Yeah, and I think you saw that a lot too with this whole idea of like lift and shift. I think has been around also when you're moving to cloud, and that happened also when you're moving to Kubernetes. A lot of people, they just said, "Oh, I'll take my server and make a container out of it and run it on Kubernetes." It's like, yeah, you can, like, but is that really what you want to do, or do you want to kind of leave the thing alone, and as you're evolving or building new stuff, you build it onto that, and that's why Kubernetes has been around for a while, but I think now it's finally become sort of I'll call it a standard, like a kind of like the de facto choice, and not for everybody, but it's the kind of thing where it's no longer a gigantic ask to say, let's move everything to Kubernetes. It's like, as time has gone on, you've kind of evolved and kind of moved on to it kind of
Well,
natively.
and I love that point that you kind of touched on where, you know, uh, I talk a lot about this idea of kind of future proofing, right? Like moving to the next new technology doesn't necessarily mean it's the right move for your specific business and what you are trying to specifically achieve. There's always going to be something new, right? So doing that really intentionally and in a way that makes sense for your business and having that flexibility um, is really, really important.
Yeah, and so I love what you just said there about flexibility because that is one of the other benefits of kind of an event-driven architecture is you're not just grabbing everything and ripping it out and moving to something new. Instead, the event-driven aspect of it is like, okay, you're spitting out events, and it's going to some target, right? And let's say you want to change the target because something new came out. You can now, split the event off and say, all right, I'm going to keep my current flow, but I'm also going to kind of split off and start sending things to the new thing, and so we could test it out. And then when we're ready, we'll kind of shut off the old one and kind of do a seamless transition, right? So that's one way of doing things. And we've talked to customers who are like, "Yeah, we're on AWS now. I don't know where we'll be in 3 years, right? So I don't want to feel like I'm locked in, but I want to get the benefits out of AWS." And it's like, great, let's do that. But with the event
Yeah.
driven nature of it, you can then say, you know what? If in the future you start spinning us some Google Cloud or some Azure or whatever it might be, or some cloud we don't even know of, someone might spin up in the next 3 years. Who knows? And it's like, now you have that flexibility to say, I want to change my target, I want to change my source, I want to, without just like ripping everything out. You can just kind of start, tweaking things. And I think that's a much smoother transition to modern technology of today, but then also technologies that we don't even know exist yet, right? There's going to
Right.
be a next evolution, and you want to be kind of prepared for moving to that without ditching what you have.
Yeah, kind of having that foundation in place to like move quickly, but kind of incrementally benefit from those improvements.
Exactly. Yeah, the incremental. I think more and more people are coming around to that as an
Yeah,
instead of just I'm gonna take everything I got and move it all at once. So I think that
absolutely.
definitely helps.
And I'm curious now, is it kind of something then, everyone can benefit from, or, how do you know if you're ready for if an event-based system is really the right protocol for you and your business?
Yeah, I would say in a way, a lot of people are probably doing some event based stuff, and they don't may not even realize it, right? So
Yeah.
again, if you are reading from an API and then sending an object to an S3 bucket, you're doing event driven, right? That in a way, you're doing event driven. So the event may be different for each different thing you're doing, and I think that's where we at TriggerMesh we're trying to help people get to the point of standardizing those events. We use the cloud event specification from CNCF, so it's like standardizing the events. That makes it so everything's talking the same language. Being able to change sources, change targets, plug into things, have chain these bridges together. You're probably doing some of that already in a weird way, and maybe you don't even think of it like you're doing event driven architecture, but you're probably doing pieces of it. And so by kind of getting all of that into one kind of known state, and then again using the technologies available to you, so Kubernetes, auto scaling, things like that, serverless being scaled down to zero and not wasting resources. So it's like there's a lot of these benefits that you want to get, and so I think that's kind of where we're going with it is taking some of those ideas, from taking a source and then setting it to a target. That's not a new thing, but doing it in a standardized way, I think helps. So back to your question about, is this the right protocol for the job? You're probably already doing jobs that have that protocol, right? You're probably already
Yeah.
doing that kind of mechanism. So really the thing that I like to do is just kind of, if you take a step back, it's like, okay, when you think about multi-cloud, are you just thinking about AWS and Azure, or are you also thinking about all the SaaS applications that you use, all the different storage locations, people's laptops, like where are you putting stuff? Where are you getting stuff from? What are your custom applications doing? Where are they sending it to? Are they sending it anywhere? Are you storing your logs in Splunk? That's a cloud, if you will. So it's like, those kinds of ideas, um, you know, I think they all kind of tangentially relate to event driven. So if you can kind of get your hands around all of that, I think it just makes your life easier if you do that.
Yeah, it almost sounds kind of like almost, I don't know if this is the right word, like a cultural or like mindset shift, right? It's like the way of thinking about it.
Yeah, just like the principle of event driven. Like I said, it's like you're probably already kind of doing it, and so if you can make that more of a standardized thing, then the next time you go to do something that's event driven, you'll recognize it, and two, you'll have the
Yeah.
tools in hand to do it, and three, if someone else comes to you and says, I got this problem, you can start thinking of it like, okay, I got a source, I got a target, I'm doing some kind of transformation in the middle. I can do that, and I have those pieces in place, and now that's why we try not to be like, oh, this is the way you have to do it, but more of, we're providing ways for you to figure out how to do it, and I think that's better for you long term, because you're every time we go into a customer, everything's unique, right? Because that just how it is. But being able to adapt to it and keep that mindset shift, like you said,
Yeah.
is, I think, really important.
We talk a lot about this internally, but I've also noticed this in some of the other episodes of Kongcast that I've done. Is like it's about giving people the building blocks more, and I'm seeing that kind of consistent trend in the technologies that are taking off. Like not prescribing your way of doing things, giving them the tools to help optimize what they need to do.
Yeah, and it's a little scary too, because like sometimes you come across a tool and you're like, it's like, we can do anything. It's like,
Yeah,
yeah, but that doesn't help me. And that's where we try to have like examples of things like, okay, well, here's something that we have had someone do. And so, again, going from old to new, we literally have been working with someone who's working with IBM MQ, which is on a a mainframe, is spitting out these fixed width format things, and they need to run COBOL copybook files, which I had to look up what it is, because it's older than I am. It's the 60-year-old technology, but it's still being used at these banks because they're like, oh, it works. I mean, it does what it needs to do, but none of the developers know how to work with it. So it's like, what they needed was, okay, we got this source, we're transforming it using a copybook, and then we're going to spit it out as like a JSON format into a queue that our developers can read from. And it's like, as long as you can get it on that queue in a JSON, they can read it and they can figure it out from there. And so it's like, those are the kind of examples where it's like, yeah, we can do that. And then when you say that, then they're like, oh yeah, but I also have this other thing. It's not a copybook, but it's something else. Got it. Now I understand what you're doing, and I can now adapt it to what I'm doing.
yeah. I think that's such a beautiful illustration of the benefits of modernization, right? And like optimizing for developer experience, but not ripping out those things that are still working in your system just because there's like this new technology that's come along.
Yeah. And there's an old article by Joel Spolsky, I think his name is, who made Stack Overflow and a couple other things, and he was like, basically rewriting software. Like, you never want to just fly. Everyone wants to rewrite software, but it's like, you shouldn't, because that's what kills it. Because then
Right.
you're like not innovating, right? You're not doing anything new. So if the stuff works, like, it works, and there's reasons why it has all the stuff in it, but it's like, you also need to again adapt to what people need to do with it. So by making it
Exactly.
modern, but if you can make it modern easily without getting rid of the old, then you're gonna win. So
Exactly. So I'm sure you're seeing more and more of these things on a daily basis. You're in the weeds on this stuff, but what are kind of the most common use cases you're seeing here?
yeah, I think I just mentioned one about modernizing off of kind of old legacy, we call it, which some people get offended by that. If you work for a legacy vendor, you get offended by that. So kind of modernizing that and helping people get to cloud native. The other thing, one of the ones that's really been resonating, is we've been working with this open source. It's called the CSNF, so it's Cloud Security Notification Framework. So it's this framework for basically taking all these security notifications from all these different cloud providers and trying to do something with it. Because it's like, okay, Azure has these notifications that happen, but they look different than Oracle Cloud Guard, and it looks different than the AWS version. So what they did is they took TriggerMesh, they kind of put it in the middle and said, okay, we got all these sources, which is all these different cloud providers, and we're standardizing the event. So we get all these events coming into TriggerMesh. TriggerMesh takes them, standardizes the events, adds a few attributes that are specific to this kind of framework, the specification that they have, and then now we have a standardized event from all these different sources, and now we can do something with it, right? So now we can take that event, we can put it into Microsoft, I think it's called Guard Duty, or maybe that's the Amazon one. Anyway, they all, that's the fun part of keeping up with cloud, is you have all these names of all these different services.
Yep.
And so, so you can send these to all these things. You can also send it to Splunk. You can send it to Slack and notify your security team. So that event standardization is a big thing. Again, if you're working in the multi-cloud world, if you just have all these different sources of things, sometimes you just need to kind of like funnel them all down into one thing. And now it's like, okay, now I know what to do with it. So that's it, been resonating a lot with people who have to deal with those kinds of things. They like that standardized event format. It's like one thing, I know what to do. So those kind of events. And then the other thing that we found is, we've got some people coming from the MuleSoft world where you write these, they call it data weave, which is like a scripting language. And it's like, yeah, our developers kind of developed this data weave. We don't want to throw it out, but we kind of want to run it. And it's like, okay, well, we can take the data weave script, or we can take your Python script, or we can take your existing JavaScript or whatever language your developers work in, Spring Boot, whatever it is. And it's like, okay, that's doing like the business logic and the data transformation. We can drop that into TriggerMesh, and now we deal with the sources, we deal with the targets, and then you wrote the transformation, and we can use what you have. So again, it's like meeting developers kind of in the middle of, you've already done the work. We can help you with the plumbing and kind of marry the two together.
Yeah, and I like that, we talked about sometimes with those building blocks that there's like a little ambiguity with all the things you can do, but it sounds like, with you seeing that all day to day, it's nice to have like a partner that can help with some of those best practices. Like, here is what you can do.
Yeah, exactly. Yeah, here's what you can do. Here's what some of our other customers have done. We've seen this work well. We saw this not work so well. I mean, you can still
Yeah,
do it, but maybe that's not the best choice. And sometimes just getting that push in the right direction is, again, we're not trying to tell people what to do, but we try to just kind of help them, figure out what's best for them. And
yeah,
and and that's where I get excited by, someone saying, okay, we got to figure it out now. We got it plugged in. We're doing it this, I'm not a Java developer, but hey, we wrote it in Spring Boot. It's like, cool, that works for you. Great. Then, we can
yeah,
work with that. So,
absolutely. And so, obviously, we're going to dive into seeing some of this in action today within Trigger Mesh itself. But can you give us just kind of a quick overview of what exactly Trigger Mesh is to set the stage there?
yeah, so TriggerMesh is, so if you're familiar with Knative, which is, it's basically serverless on Kubernetes, we're an extension beyond that. So we use Knative under the hood, plus more extensions beyond what that is. And so basically what we're trying to do is we run as microservices on Kubernetes. So I mentioned microservices earlier. We run as multiple different containers on Kubernetes, but we're basically providing a kind of a serverless function capability for you on-prem, if that makes sense. So we say on-prem, really just on your own cluster. So what ends up happening is, again, you get all the benefits of Kubernetes, which is we scale up as many times as you need. So if you have millions of events coming in, we scale up as much as we need to. We're also scaling everything down to zero when it's not being used. So if you have things that aren't being used, it just doesn't take up resources. So we handle all that for you. And I've kind of talked a little bit about kind of event sources, event targets, and transformations. That's really the basics of what TriggerMesh is. We build these bridges, is what we call them, or event flows, whatever you want to call them. And so basically, you define a source, you define stuff that happens in the middle, and then you define a target. And that stuff that happens in the middle can be transforming the data, it can be running these functions, it can be splitting or routing events based on attributes that come in. And so really that's kind of what we're doing, but you can have multiple sources, you can have multiple targets, or you can have kind of more flat flows. But by building these out, again, you're be able to define these. You define these in code. So it's if you've heard of like infrastructure as code, it's sort of like integrations as code, right? So it's you're defining these integrations. They're all codified, and so you can put them as a part of your CI/CD pipeline. Store them in GitHub or wherever your Bitbucket, whatever it is. And so now you have these defined flows. You can update. You can provide these APIs to developers, and they know exactly what they do. They can describe them and figure out, what's the here's the input, here's what the output's going to be. So, and I know that's a lot, but and it's a complicated tool. But the simple way of thinking about it is, okay, you have stuff over, as a source. We're gonna send it through this filter, and then we're gonna spit it out on the other side. And so that's how we kind of help again with that plumbing of getting those events from the source to the target.
Yeah, and that'll be the benefit of seeing it in action. But as we're diving into kind of this use case of it, you're going to be showing it with Kong Gateway. What in that context? What's the benefit of Trigger Mesh plus something like an API gateway together?
Yeah, so one of the nice things that we did with Kong, we found that So we actually wrote a Kong plugin. It's an open source, and we'll have the link somewhere. And so I mentioned this idea of cloud events, and so we take this cloud event specification, which is and I'll show you what a cloud event looks like as we get into the demo. But it's basically, you have a payload and you have some attributes, and it's sort of a defined object. And so these cloud events, we created a plugin so that the Kong API Gateway will spit out cloud events. So now you can have the Kong API Gateway as the source, and then TriggerMesh kind of does the rest, right? So now your developers are sending events, just curl requests if you want, to Kong. That's what I'll be showing in the demo. But it can be more complicated than that. But it's like, now I'm sending it to Kong. Kong takes that request, creates the cloud event, pushes it into TriggerMesh. TriggerMesh does any kind of transformation, routing, splitting, whatever, and then puts it on the target. And the target could be sending it back to Kong, right? To say, hey, here's a reply to your API request. Or it could say, put it at an S3 bucket or put it on a queue or, whatever it might be. So we found that, it's kind of, you're getting the best of both worlds. You're getting the best of Kong, as kind of the front, and TriggerMesh is the back, which is, I guess that's a simplified way of putting it, but it's like, we found that, when we show this to people who, they're like, oh yeah, we love Kong. Kong is the gateway, perfect. TriggerMesh is doing the transformation, perfect. Like this works really well together.
Yeah.
So we found anytime we show this to people who are even passingly familiar with it, they're like, oh yeah, this is perfect. This is exactly what we
Yeah.
want. We love Kong, and now we're getting this data transformation with TriggerMesh.
That's awesome. Yeah, it kind of clicks. Well, cool. I'm super excited to see it. So how about I hand it over to you, and we can dive in.
So what I'm going to show here, I kind of mentioned this, as we were talking earlier, is this is going to be some examples of using TriggerMesh as a transformation, right? So we're getting an event source. Right now, the event source is going to be Kong. And so we wrote, some of the cloud event plugins, and you can see here's some of our Kong definitions. And so you can see here's the plugins. And so we're saying, hey, use the cloud events plugin, and here's the event type. And we'll show you what this looks like here. But basically we're saying, hey, stick this event type on the cloud event definition, and then, sending it to a path. And this path is now pointing to our Kubernetes cluster. It's pointing to the TriggerMesh, transformations. And then inside the transformations, this is what a transformation looks like. So we have defined one. Again, I kind of talked a little bit about MuleSoft data weave. So this is an example I'm going to show here, which is the kind here is a data weave transformation. So this is going to create an object of that type. We give it a name, and then here's where we just define the spell. So again, this is the data weave language. They call things spells and spell books, and they have all sorts of language around this. And so basically, we're defining that. In this case, we have to define what's the input and output. So the input's going to be XML, the output's going to be JSON. Basically, what this is doing is saying, hey, we're just going to create a payload that uses the original payload, and we're going to kind of format it into a JSON format. So it's doing a lot of magic here, but basically all that's saying is you send in XML to Kong. Kong is going to take that XML, put it in a cloud event, send it to TriggerMesh. TriggerMesh is going to take it, run the data weave, and is going to output JSON. And then here's where you define where the output goes. So in this case, we're going straight to what we call TM debugger, which is really just on the left side here is going to be an event viewer. But this could also be, again, a queue. It could be, block storage. It could be to another custom service that you write. So, you can define where this ends up going. In this case, we're just going to send it to our browser so we can see what the event looks like. So I'm going to go ahead and send this giant payload. It's really just XML information. And you can see here's where we actually see the cloud event. So this is an example of what a cloud event looks like. It's got the data here. So this passed through Kong. It passed it along. It kept the original source, which is just a curl request. And then Kong added this type on here. So it said, hey, this is what we discovered this is going to be. So we're saying, hey, this is the type. And then it outputs this data. So, I think a cloud event, when people who haven't seen it before, they're like, oh, that sounds scary. It's really just, a definition of what these attributes are. And now we have the payload. So it's really nice because you can modify this and then just if you're familiar with kubectl, you can just apply this manifest and it updates it right in line. And so It's that easy to update. It's that easy to define a new spell. And then you can do some really complicated things. I'm not going to run through this whole thing, but this is, I mentioned earlier, an example of taking an IBM mainframe and sending it to SQS. So what we did here is we defined this entire thing is about 150 lines of code. And so we're doing all these definitions of all these different pieces of the bridge so that you can read from MQ. So I'll show you what the reading from MQ is. So this is the source. Here's IBM MQ source. And we're defining just some of the connection details. We've stored the secrets. And then we're saying send it to a broker. So this is one of the more powerful things in TriggerMesh, where you have a broker, and the broker can have some logic around whether they're splitting, routing. Depending on the event type, it can go to certain paths. And so now we can see, if I come down here, here's where we actually define the broker. And then we're saying, here's a trigger. So this trigger here says, if the type is IBM MQ message, then we send it to the copybook transformation, right? So specifically, if it's that type, it's going to go through this copybook. So again, this is COBOL stuff. It's 60 years old. I can't even tell you what it's doing in here, but we basically said, okay, here's the copybook. And so then it sends it back to the broker. So the cool thing is it kind of routes through, and then the broker sees it and says, okay, here's the next trigger, which is saying if it's a message response, instead of sending it back to copybook, we're instead going to send it to SQS. And so here's the definition of SQS. So it's these kinds of definitions where once you start building this out, it's kind of like you mentioned earlier, building blocks. You're kind of piecing together these things to then say, okay, from here, send it to here, and then send it back around to the broker. Now it's got a different event type. Now we're going to send it on to the target. So you can kind of set these up to be a little more complicated, but it makes it so all the logic is in here. So now your developers just say, yeah, the mainframe's spitting it out. Cool. It's going through all this transformation, sending it to SQS. Cool. I can read from SQS. It's a JSON now. I don't have to worry about copybook. I can just run it. So it makes it really simple to do this whole definition in 150 lines of code. And now we're running on SQS. Now we're basically cloud native, right? Instead of legacy mainframe, now we're cloud native. And it's like, when you say it's that simple, it's great. And you're getting all the benefits of Kubernetes, all the benefits of serverless, and all the benefits of cloud native.
Awesome. Thank you so much for the fantastic demo and kind of showing us, walking us through all those things and helping piece together everything that we've been talking about. We will definitely include some links in the description so that you can learn more. We'll include the link to this demo directly so you can dive in if you want to do it yourself. But Chris, any other kind of final thoughts to leave the audience with today?
Yeah, the only thing I think I forgot to mention is that TriggerMesh is fully open source. So we're big believers in open source technology. We love contributing back. We contribute back to the Knative project. We have these open source tools. And so if you go to github.com/TriggerMesh, which is our organization name, and then TriggerMesh/TriggerMesh is our actual code. Like, you can go and download it and run it. It's open source, open issues. Talk to us. We also wrote that Kong plugin that we open source because we were like, hey, we love Kong. Let's open source this cloud events plugin so that you can run that as well. And we wrote some blogs around how to use these. We have a Slack channel where you can come talk to our developers in our community and work with them. But we're big believers in open source. We're big believers in contributing back. And so feel free to check it out. Obviously you can find me, and if you have any questions, I'd be happy to help. But it's just one of those things where we're definitely excited to give this to the community.
I love it. Absolutely. Absolutely. Well, awesome. Thank you so much for taking the time to speak with me today, Chris. This has been fantastic. And thank you to everybody who has tuned in to join us today. We'll see y'all next time.
Thanks.